Hi there, it's Mrs. Hall. So today we are going to be learning about the first derivative, which is section 16.2 in your textbooks, in case you need to look it up. It's also on page 310 if that helps. Alrighty, so thinking about what we just learned about slopes and finding slopes of a line. So we used the formula m was slope. So I2 minus y1 over x2 minus x1 was the formula for slope. So using that formula, we were easily able to find the slope of a straight line. However, there is more involved in finding slope for a curved line. So the slope of a curve is the slope of a line tangent to the curve at a specific point. So if I'm looking at this graph here, let's say I wanted to know the slope of this curve at this point. You would have to create your tangent, which I already did, and you would find the slope of that line. The slope of the tangent is equal to the slope at this point. So therefore, a slope varies at different points along the curve because there will be different tangents. As you can see, there's one tangent, and here's a different tangent at two different points in this graph. The slope will vary at different points along the curve. This is the symbol for delta. This is delta itself is a triangle. So when finding derivatives, we use delta x, which represents a change in x. So if you could follow this arrow here, x2 minus x1 is the change in x, so that becomes delta x. Alright, so the definition of a first derivative gives you that the slope of the tangent is equal to the limit as delta x approaches 0 for f of x1 plus delta x minus f of x1 over delta x. This is the exact same formula below, but it's a lot easier to understand. So please refer to this formula. It's the same thing, but instead of saying delta x, we're saying it's h. So it kind of simplifies it a little bit more. So the slope of the tangent is equal to the limit as h goes to 0 for f of x plus h minus f of x over h. And when we find the derivative, we know we have f of x. F prime of x, that's a symbol for the equation of the derivative. So when we find the derivative, instead of being f of x is equal to, it'll be f prime of x. So this little line here means prime. Okay. Alright, so let's go ahead and look at an example. The example says find the slope of a line tangent to f of x equals x squared when x is equal to 1. Alright, so first and foremost, I want you to find f of 1 plus h. Again, I'm using this formula here because I find it easier. And I think it'd be easier for you all as well. It's the same thing, same steps, but instead of seeing all this delta x, it just makes it h. Alright, so f of 1 plus h. Every time I see an x in my f of x, I'm going to turn it into 1 plus h. So I have x, which would become 1 plus h squared. Do you see how 1 plus h became my x? Alrighty, so now we want to find f of 1. So every time I see an x, I'm going to put a 1. So now I have 1 squared. And 1 squared is equal to 1. So now we're going to plug it into the formula. So I'm going to pull this forward so we can see it. So the first things first, you need f of x plus h, and f of x plus h became 1 plus h squared. So this becomes 1 plus h squared minus f of x, and f of x is 1 over h. Okay, so I took my solutions. I took my answer to f of x, and that became, f of x plus h, and plugged that in there. F of x became that, and I plugged it in with 1 because I wanted to know when x was 1, and then over h. So now we're going to simplify and find the limit. So let's first simplify 1 plus h squared. I'm going to pull that to the side right here. So if I have 1 plus h squared, we learned how to square a binomial, so you should be able to do this part. You square the first term, square the last term, multiply everything together. So 2 times h is 2h times 1 is still 2h, and it's a positive 2h. So these two highlighted portions here are equal. So now I'm going to replace that into my formula. So I'm going to do the limit as h goes to 0 for 1 plus 2h plus h squared. I'm going to plug in the rest of it now, minus 1 over h. Notice how my 1 minus 1 will cancel. So now I have the limit as h goes to 0 of 2h plus h squared over h. We cannot directly plug this in just yet because they want to know when h goes to 0. If I put a 0 here, a 0 cannot be in the denominator. So we need to try to simplify this to where we don't have a denominator. So let's break this fraction apart and have it as 2h over h plus h squared over h. Alright, so my h's here will cancel. This h will cancel with the second h. So now I have the limit as h goes to 0 for 2 plus h. I do not have a denominator. Now I can plug in my 0 for the h. So now I have 2 plus 0, and 2 plus 0 is 2. So therefore, the derivative, which is the slope of the tangent, when x is 1, is equal to 2. Okay? Let's look at another example. They want you to find an equation for the slopes of lines tangent to f of x is equal to x cubed for any x. Alright, so I'm going to write down my equation here, my formula, so I don't forget the definition of the first derivative. Alrighty, so using this, we're going to find an equation for the slopes of lines tangent to f of x cubed for any x. They do not tell us that x is a certain point. They want to know for any x. So I'm going to plug in x for my x, okay? So x's will not change. Alright, so first and foremost, let's find f of x plus h. X plus h, well, my f of x is equal to x cubed, so my x will become x plus h cubed, and then f of x will be equal to x cubed. I replaced my x, the next nothing changed, it stayed the same. Alrighty, so now let's go ahead and plug this in. So f of x plus h is, let me write my limit first. Make sure you always write down the limit so you don't forget to do that. So f of x plus h was this. Minus f of x, and f of x is x cubed over h. Okay, just write that back down. Now let's go ahead and simplify this. So I'm going to come down here real quick. Actually, I'm going to bring it to the side. X plus h cubed. We've done this before as well. You should know that it is x plus h times x plus h squared. X plus h times x squared plus 2xh plus h squared. Now distribute x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed. Now we add our like terms, so we have x cubed plus 3x squared h plus 3xh squared plus h cubed. So this part here is the same thing as this. I'm going to replace that into my formula. So the limit as h goes to 0 is now and I'm going to have my minus x cubed from the top, and then all over h. Notice how my x cubed will cancel. So now I have 3x squared h plus 3x h squared plus h cubed over h. So you can go ahead and separate these fractions for each time, or you can factor out an h. So I'm going to do that because it'd be easier. So I'm going to take away an h from everything. So if I took away this h, take away one of these h's, so this becomes just h. I'm going to take away one of these to where it becomes squared. So I have 3x squared plus 3xh plus h squared. Now I can cancel my h's. Now I don't have a denominator, I can plug in 0 for h. So now I have 3x squared plus 3x times 0 plus 0 squared. 0 squared is 0. Anything times 0 is 0. So it gives me my final answer would be 3x squared. So the slope of the tangent is equal to 3x squared. That would be your final answer. Alright. Using this video, I want you guys to go ahead and work on number 1 from page 314. I'm going to type that into GoFormative as well. Don't forget to use it at the points corresponding to x equals negative 3.